Hey everyone, this is Andrew, and today I'm going to keep working on my SFML tutorial. If you haven't opened your project in a while, to get back into it, you need to go, if you did the same steps as me, to your C drive, users, source, repos, and then whatever you named your project. And then you can just double click on the solution file here and it should pop right open. The last time we left off, we added a character sprite and an enemy that just walks towards you, and then you have an axe, and you can hit the enemy with your axe, and they disappear, and then they'll appear somewhere else on the screen. The next thing I like to do is just add some very basic level editing. So I think we'll do this with a just a very basic tile map, and then I know that a lot of people handle the level editing using a text editor to first build their levels using like ASCII characters, and then they import the level. But I don't think that's actually a good long-term solution because, just looking at a text file and looking at the ASCII characters, it's hard to kind of get a vibe for what that actually is going to look like in game. And also, it really only allows you to have the background saved in the level editor. You can't save like enemies over top of it because they'll need to be, over top the background. So you might need multiple text files to do one level. So instead, what I'm going to do today is I'm going to set up a very basic level editor. We won't be able to save the levels today, but we'll be able to create levels and move around in the level. And we'll also do a little bit in our project to just be a little bit more organized. So let's get started. The first thing I'm going to do is right click on the tutorial, click add, we'll click add new item, and we're going to add a new class, and we're just going to call this game. Very basic, sure, okay, cool. We have our game here. And then inside of our main class, we're going to cut out everything that we have so far. So I'm going to cut out everything from here. And then inside game, I'm going to add an update function. Let's add that real quick. And then inside of the update function, I'm going to just paste everything. We'll get a lot of red errors, but don't worry about that right now. We're going to add a basic destructor that does nothing, a basic constructor that does nothing. The next thing that I'd like to do is move these math helper functions into their own file. So we're going to right click on our solution again, go add, new item. This time I'm just going to make a header file, and I'm going to call it math helpers. Go back in here, we're going to cut out our math helpers. In my header file, I'm just going to paste them, and then I'm going to put these inside of a namespace, which just wraps them up so they're not just floating in the like global namespace, and I'll just call it math helpers. So you say namespace, do curly brackets, and then you can just put all of this inside of that. And then in here, we'll include SFML graphics to account for things like SF vector. And then when we go back over to game, in game.cpp, we'll include graphics, and then we'll also include our math helpers. And then, sorry, inside the update, let's make the update actually return. Yeah, we'll have the update return a bool, and it'll return true if we want to keep updating, and it'll return false if we are done updating. So if the user closes the screen, we'll return false. And then at the very bottom, the default behavior will just be return true. And then you'll see that our math functions still have some squiggly lines behind them, and that's because they live in a namespace now. So we'll have to type math helpers, : and this is the scope resolution operator. So you say normalize is inside of the scope called math helpers. So we'll type that in a couple other spots, math helpers, and then now this is all happy, it looks like. So if we go back to our main CPP, now we don't need any of these files anymore. Instead, we just need to include one file, and that will be game.h. And then we can just make a game. And then we can say while the game is updating. That's fine, actually. So while the game keeps returning true, we'll keep doing this loop, and then whenever we're done, the loop will get kicked out. We'll get kicked out of the loop, and then it'll just return 0 out of main. And this might be enough to compile and run. I saw we had included random here before. I'm not sure where random was being used. It must have been something I was using before, but not anymore. So go back here, click run, and perfect. We have the exact same game, but our main is just much simpler. Fantastic. Let's close out of this. Close out of this. Okay. And now the next thing I want to do is I want to have a couple game modes. So I want a game mode where we're playing the game, so we control the character and all of the enemies move and whatnot. And then I want to have a game mode where we're building the map, or the, like putting tiles down on the screen, maybe putting enemies in their place. For this project, I'd like to stay away from procedural generation because I think it's just like a little overkill for this. So I want all of the placement of the tiles done by hand. So we'll add a public. Well, I suppose we don't need to say public because it's already public. We'll add an enum called game mode. And the first game mode, we'll say play, sure. And then the second game mode we'll call level editor. And then we'll just add a private bool here, or not a private bool, sorry, a private enum called game mode. And then we can just initialize the game mode to the play. And then I'm going to add some private functions, and I'm going to add an update for each different type of play mode. They're also going to return bools. Sorry about that. Also, if you're curious at how my Visual Studio fills in the text so quickly, I've been using GitHub Copilot lately, and I've really been impressed with it, so I highly recommend it. I think you can do a free trial for maybe a month, and then I think it's $10 a month after that, so it's not too expensive. I think it's worth it. Like the amount of development time that you save is pretty insane. Anyways, up here in our update, let's add a switch statement where we're going to switch based off the current game mode. And then we'll say if we're in play, return the play update. And if we're in the level editor, do the level editor update. And then I'm going to move all of my existing code into the play update, because that's what we're doing right now, is just playing the game. and then we'll need to return true at the very end here. Okay. Okay, fantastic. And then I purposely left the window out because if you'll notice, what we were actually doing before is every time we were doing the update, we were actually, I don't even know why that wasn't breaking before. Just thinking about it, maybe that's a little bit of little magical. Okay, fair enough. Why it was working before was because we had this while loop where it says while window is open, keep processing the events. So the window was never closing, but we're going to change this up a little bit. So instead of having this window just sit in the middle of nowhere, instead what we're going to do is we're going to add a window to the class itself. So I'll say SF window. I like to do capital letters. And then when our game is created, we will initialize the window. So we can actually just cut out all of this initialization here. And then inside of our initializer list for the window, we can put that in there. Okay, so now when we create the game class, we'll create a window, we'll set the game mode to play, and then we'll call update. And let me think here just a little bit. So instead, I'm going to change our update function to a run function that returns void. We'll just change that over here. And my idea here is that we'll run the game until the window is closed instead of doing this while loop, which is probably a little bit cleaner way to do this. So now we'll just say, we'll say game.run. And then whenever the game is done running, we'll return 0. So if I go back over to the game, now we say run, and instead of this, we're going to say we also don't need to, we can just have this be an update, where we say update play, update level editor, and then we can move this part to wrap the whole game mode. So now we'll say while, and this is now a member variable, so we can just say while the window is open, do our updating, and our time step will be in here as well. Perfect. Window. These windows, we can just say window. No problem there. Let's kick this out of this big update here. These updates also don't need to return a Boolean anymore. So I'm going to change these both to void as well. Void, void. We can change this to void. Change this one to void. Okay, now it doesn't need to return anything. We can just return here, no problem there. And then, okay, time since last frame. Okay, looking at this, I'm thinking that we'll actually need probably one more function. The update play and update level editor can dictate whether or not we're moving the character and playing the game, or we're putting down tiles. But in both scenarios, we want to draw everything. So I actually need to pull out all of the drawing functions. So I think I'm going to add a new function called draw, which sounds good to me. So we'll just say draw. And this is where we're going to draw everything. So regardless of whether you're in play or you're in level editor mode, we want to see the same thing. Changing between the modes should not, change the whole game. So for now, when we draw, we want to clear the window And if you remember, window is now a member variable. So we will change that to access the member variable. There we go. So we'll clear, we'll draw the enemy player X, and then we'll display it. And then now the enemy player and the X, we don't have access to those things anymore. So we need to save those on the game as well. Okay, the next thing I want to move to the class is this time update. So we're going to cut this out. We're going to move it into the game itself. And it's pretty common to call this something like delta time. So this will be the time since the last update. And every time we run through here, we'll grab that by calling clock restart. And then we can just use that throughout the functions. That'll be saved. And then this will be the window. The next thing I'd like to do is move our axe, our enemy, and our player sprites into the game class itself. Right now, every time we call update play, they would be created. So let's add 3 sprites, SF sprite. We'll call this player, enemy, and axe. And then all of the stuff that we did in the second episode where we set up the player, sprite, and axe, we can now do that at the beginning. I think we'll also need to save the textures because sprites take a reference to the texture. They don't actually copy the texture. So the texture needs to persist forever. It can't just live in this scope. So I'm going to additionally include a texture, and we'll call this player texture, enemy texture, and axe texture. And these will probably end up going away, but for now we can keep them. So we don't need to create a player texture here. Instead, we say our player texture does not want to cooperate with me right now. Player texture. So we'll load the player texture. Then we'll set the player texture on our player sprite. So we can go player sprite dot set texture. For some reason, my Visual Studio seems to be lagging quite a bit behind. Not very happy today. Oh, because I've just called the player sprite player, which is fine. Okay, so be it. We'll say player, and then player doesn't actually have a function called set texture. Let's see what it is. So I would have thought that we have a set texture. Oh, lowercase s set texture. So let's do that real quick. Go back into our game. Lowercase s set texture. We'll set it to the player texture. And then we'll say player set the scale, set origin. And then let's do the same thing for our enemy texture. And then, okay, we're closing in here on fixing this up. And I promise this is worth it. You really don't want to keep all of this inside of main. It really restricts you from, you know, having complicated programs, like allowing you to go in between something like a play and a level editor. Okay, so now we need to change all of the instances of something like player to the member variable player. So player. We're going to draw a player, and then we need to do the same thing for axe. So axe, draw the axe. I missed this one, player. And then we'll do enemy, enemy, player. There's a lot of these, but it's definitely worth it. Let's get this done. Okay. And then enemy here. And then let's just do a sanity check to make sure we have everything how we expect it to. So when the game is created, we'll load the player texture. We'll set the player texture on the player. We set the player's scale on the origin. We load the enemy texture. We set the enemy texture. We set the enemy's scale origin position. We do the same thing for the X. And then when we run the game, we get this clock and we say get the delta time, and then based on the game mode we'll go do the game update, and then we'll draw everything to the screen at the very end. In the update play mode, if the user closes the window, we'll close the game. I feel like this could probably just live inside of the update as well. We don't actually need this return here because the next time we come to the top of the loop, the window will be closed. But we want to be able to close the game regardless of whether we're in play mode or if we're in the level editor mode. Okay. This just handles all of the logic that we had before. The level editor does nothing. And then if I just take a little peek in main, it just says run. So now if we play the game here. Oh, see, I did think that we needed to do this. Sorry. If your holy cow. If your Visual Studios has been yelling at you the whole time, I'm sorry. You 100% need to include graphics in the header file for the game. That's how it knows what sprite, texture, window, time is. Hey, sorry, one blunder here. This should be SF render window, which that also makes sense why I was getting yelled at so much. Okay, so now with that set to render window and everything else sorted out, if we click play, we should once again be at the same place we started, but now we're set up just a little bit better to handle what we have coming up. So the first thing I'd like to do is add a button to allow us to switch between the play mode and the level editor mode, and then just have a very little text at the top of the screen that tells us which mode we're in. Okay, in order to allow the user to change between the level editor mode and play mode, I'm going to add a function called handle input. And then if we just create a definition for that, inside of handle input, I am going to check if keys are pressed. And if they are pressed, then we'll save certain information. So all I want right now is when the user presses T for it to toggle between the two modes. Okay, so then we have our handle input function, and we'll say if SF keyboard is key pressed, SF keyboard T, then we want to change the game mode. So we'll say if the game mode is play, then set the game mode to level editor. And if in the other case, I suppose, we only have two modes right now, set the game mode to play. Now, what will happen right now is if you press T, it'll quickly switch back and forth between these. And what we'd really like to happen is to do this only when you press the key down, not if you hold the key. So just as a quick trick, I'm going to add a static Boolean here, and I'm going to call it T was pressed last update. I'm going to initialize it to false. And I'm going to add a condition here where we say if T is pressed and it was not pressed last update. Oops, sorry. We don't want to add this here. That's not what we want. Okay, when you press T, we say if T was pressed, if it was not pressed last update, then do our logic. Set this up like this. Else, we know that T was not pressed. So if T was pressed, try to do the game mode switch. Else, we know T was not pressed. Oh, duh. Okay. If T was not pressed last update, we need to set this to true at some point. Okay. So we'll say this. If you press T and it was not pressed last update, do this. And then we also need to, make a note that is pressed. Okay. Now if we run the game, everything will be the same. If we press T, the game freezes. That's because we're now in our level editor update. And then if we press T again, it unfreezes. Press T. Cool. So now let's close out of this. And I'm just going to add some very basic text. So we can say SF text. And we'll say this is the game mode text. I'm not actually sure if there is a default font available for text. So let me check real quick. So unfortunately, it looks like there is not a default font. So what I'm going to do is I'm going to use the same font I used for this other project I have called Crayon. We're back here in the File Explorer. You can see all the files we've already added today. I'm going to add a new folder though, and I'm going to call it fonts. And then I'm going to copy this Crayon font over here. You can copy any font you want. There should be some fonts defaultly saved on your computer. There are tons of free fonts online. I always download the TTF TrueType font files. If you want to use the same font as me, you could probably find it. I'll also include a link to it in the description, and the font will be uploaded to the GitHub for this project. So you can grab it there. Okay, but that means we'll also need, alongside of our game mode texture, we'll need a font. And then before we can use our font, we need to load it. So I'll say M font here. And it's very similar to how we load textures. So you're going to point it to a file path. So I'll say load from file. And then I'll say fonts. And then it is Crayon Medium TTF with a capital K and a capital M. So Crayon medium.ttf. And then inside of the texture, we'll have to say set font. And above here, I've just put the font in the middle of the screen, and I've set the string of the font to play mode so we can see something. And then additionally, in our draw function, I draw the font as the last thing that I draw. So draw words on the screen, whatever. Now, if I run this, we'll see play mode is in the middle, and it's pretty teeny tiny, but that's okay. I'm going to close out of this real quick. Now, what I would like to do is say when we click the T button and we go into the level editor, I'm going to say game mode text.set string, and this will set the words that are displayed on the screen. And I'm going to say level editor mode, and then I'll say when we're in play to set it to play mode. And then the last thing I would like to do is to just move this a bit higher on the screen. So remember, the first value, the X value, goes left to right across your screen, and the second value goes top down across your screen. So the smaller the number is, the higher up on your screen it's going to be. And now if we see this, it'll say play mode, and when I click T, it goes to level editor mode. T back to play mode, T to level editor mode. Okay, finally, time for the fun stuff. So now what I'd like to do is set up a bit of the level editor mode. So what do we want to do here? The world is our oyster. What I think I want to do here, how I'm envisioning it in my head right now for some basic level editing, is we go into the level editor mode and we're able to place down tiles into the world wherever we want them. And then I think for now, the easiest solution to change the kind of tile that you're drawing is to use the scroll wheel on your mouse, so that at least for now, let's say we have maybe 2 or 3 tile types, it's going to be pretty easy to switch between them. So let's get started on that. So all of our tiles are going to be sprites. So, but we don't know how many they're going to be. So we can't just store, a huge number of sprites. Instead, in C++, we very typically use vectors of things. And a vector is just a fancy word for a list of sprites, or I'm sorry, a list of anything. And then that list can grow and shrink dynamically. So you don't need to know how many you're going to have ahead of time. So the first thing we need to do up top is, include vector. And then we can say std : vector. Std is just standard because it comes from the standard template library. And we'll say standard vector of sprites. So these directional, like chevron arrows, says what type is going to be stored inside of this vector. So it's going to be a vector of sprites. So it's going to be a list of sprites. And we're going to call this our tiles. Okay. And then what we'll do is when we're in the level editor mode, we will we'll do a couple of things. We're going to draw the current tile that we want to place in the world, so the player, or so the user, knows what they're about to put down. And then additionally, we'll handle the input. So if you were to, I'm just going to have it as left click to add the tile and right click to remove the tile. So you'll left click, and what we'll do is we'll find where you are in the game world. We'll create a tile there. And we'll use the current tile that's selected to put it there. And then if you right click, we'll do the opposite. So we'll find if there is a tile there, and if there is, we'll remove it. So I'm just going to write like the very basic outline for that. We'll go over here to our update level editor function, and we'll say if SF mouse is button pressed, and then we'll go mouse button left, and then GitHub Copilot autofilled a bunch of stuff. Let's see what it gave us. It says mouse position is, and this looks correct. So SF mouse has a function inside of it called get position that gives you the position relative to the window that passed in, which is the window that we are using to draw everything. And then right now it's setting the player's position to the window, which is not something we want to do. Instead, what we want to do when the mouse button is pressed is we want to create a tile at position. So what I'm going to do is I'm going to say, and sometimes I like doing this where I don't have the function yet, but I know what I want the code to ultimately look like. So you just start writing the code even if things don't exist, which is a totally valid way of coding. I feel like it's really easy to get kind of wrapped up in the OCD of the red line, the red squiggly line underneath text, and sort of avoid doing this. But this is a little faster, and I don't know, I kind of feel like it helps to just keep up with your train of thought while you're coding. So, okay, so the user has pressed the left mouse button, we've gotten the position, and we want to create a tile there. So I'm going to say create tile at position and pass in the mouse position. And then alternatively, what we want to do is say if SF mouse is button pressed, SF mouse right. Oh, and look at that. I'm telling you, GitHub Copilot is really cool. It got the mouse position, and then it says delete tile at mouse position, which is actually exactly what we want to do. And then, okay, yeah, perfect. I'm going to go create both of these functions now. So I'm going to say these are my level editor functions. Probably redundant to say functions since you'll see that they're functions, but anyways, create tile at position. And then this one says remove tile at position. I think before it said destroy or delete. What did it say before? Delete tile at position. Yep. Okay. We'll add both of these functions in. Oops. Add both of these functions in. And then right now, let me think for a second. I'm kind of curious. I don't know exactly what this mouse position is going to give us. So what I'm going to do is I'm going to output it to standard output. So if you just hash include IOStream, you can output text. If you notice when you run the game, a little black box pops up and it says some, I don't even know if it says anything right now, but you can always put your own text in that little black box by sending things to cout, which I'm pretty sure stands for console output. And then we use these fancy double arrows, which are the streaming operators. So it goes left to right, just like a sentence. So we'll say, what we want to put in the console is mouse position, and then put the X position, and then put a comma followed by a space, followed by the Y position. And then we have this standard ENDL, which is end line, which is just a fancy way of saying go to the next line. So if we didn't have this here and we kept calling this, it would span across the whole console. But with this here, it goes line by line. Let's see why it's... Oh, it put SF in front of this. This is definitely from the standard library, not from SFML. So now if we run this and we go into the level editor mode and I click on the skeleton head, you'll see, oh, this is another fun thing. So you'll see that it keeps going no matter what, even if we don't have the window focused. I don't really care about that right now. That's fine. But actually, no, it's kind of cool. You can see. So you'll see in this, maybe I'll grab this by the very corner. Can I? Does it let me? No. Okay, that's fine. We'll grab it by this corner. You'll see over here, the X position approaches like, we're past, you can go even past the screen. So we're past 1920. And then at the bottom, we'll get all the way to 1080. I know you can't see it. And then over at this side, in the top left-hand corner, it would get to 0, 0. So very cool stuff. Let's close out of this though and close this. And now we have to do just a little bit of brainstorming. Well, also we need a tile. So maybe that's the simpler place to start. Let's do that. Let's get our tile going. So let me see how I've done the other ones in this project because I've already forgotten. So, ooh, these big guys. Player.png, x.png. Sure, I'm gonna make a 16 by 16 sprite. I'll probably end up skipping through this spot. Nobody needs to suffer through my drawing. Okay, I've just finished drawing a wall. Don't hold your breath. It is very basic. Doesn't look great, but it is what it is. 16 by 16 wall. Okay, so let's go back to the game. And in here, you'll remember we have a list of tiles. I am going to additionally have a list of sprites, and these are going to be our tile options. So if you remember, what I'd like to do is, let's say we have 3 tiles that we can select from. We'll use the mouse wheel to scroll between them, and then left click will place them into the world. So we'll have 3 tile options, and then when we left click, we'll actually create a tile and add it to the tile list. And then additionally, we need to know which tile option we're on right now. So that's pretty simple. We can just add an integer to know which spot in the tile options list we're at right now. So I'll say tile option index. You could set it to 0 here, but it's probably best practice to really keep these initializations all in the initializer list. Okay. And then what I'm going to do at the bottom here is, for the tile options, I'm going to say tile options dot. I'd actually like to do in place back. So in place back constructs something in the spot, and if you remember, for a sprite, we actually need to have its texture. So for our tile options, we're going to need to have the textures. And I'm just thinking, let's just get into it right now. So you'll notice that one thing that is already happening is that we're sort of accumulating an abundance of textures. We have the player texture, the enemy texture, the axe texture, and for something like tiles, we're going to end up having, if we continue this pattern, we'll end up having something like a wall texture, a ground texture, maybe various wall and ground textures. We really just don't know, because I haven't planned anything in the future. So one thing that we can do instead of creating a texture for every sprite is we can have a texture with multiple things drawn on it, and then for the sprite, when it uses that texture, it'll just render a part of the overall texture. So what I'm actually going to do is, I have this 16 by 16 image right now, but I'm going to create a new image, and let's just keep it small and simple right now. I'm going to make a 64 by 64 image, and then I'm going to copy and paste what we just created, and I'm going to put it in the top left-hand corner. And then just for the fun of it, we're going to go to configure grid, make the grid a 16 by 16, then go to view, show grid, so you can see this. I'm going to color some of these other grids just a different color, and then we'll use these as tiles as well. And it'll just sort of be like a placeholder tile. So we don't have to worry too much about what the color is, just as much. We really just want to have a color there so we can tell that we're properly changing tiles. Okay, so now I have set up these tiles. I'm going to go export as, and here, this is where I'm going to say tile map, because it's no longer just the wall tile or the floor tile, it's a map of tiles. So I'll close that, and then we'll add a texture here, and we'll call it tile map texture. And then up here, we can say tile map texture dot load from file, and it'll be tilemap.png, which is this right here. Okay. And then for the tile map options, well, it'd be nice to do this in a more dynamic way, but because we know how big the tile map is and I don't foresee it changing for a while, we can just set up some hard-coded values here. So what I'm going to do is I'm going to say for int x equals 0, x is less than 4, plus plus x. And what I'm setting up here is a loop that goes across the tile map, and then it'll go down one row, and then it'll go across the tile map again, then it'll go down one row, then across the tile map again. And for all 16 tiles that exist, we're going to save them as their own sprite. So let's see how close Copilot gets us to a good solution. So we go across and down. We get a tile. We set the texture correct. And then we set the rect to x times that times that. Set the scale to 10. Set the position. The position doesn't matter on these tiles right now because we're not going to be drawing all of the tiles. But this actually looks more or less correct. The only thing it's missing is setting the origin, because we would like the tile to be centered, just like we do for the players. And it's not going to be 16:16. Our tiles are 16 by 16. So to put it in the center, we want to do setting the origin at 8:8, just sort of like we've done for the axe and the enemy and the player. I'm just going to get rid of this set position line because it's not important right now. The scale, that's good. The texture rect. This is also not necessarily correct. So it's going to be x times 16, y times 16. And what this does is these first two values are where on our texture sheet we're going to start from, and the second two values are the width and the height. So for example, when x is 0 and y is 0, we're in this top left-hand corner at 0, 0, and then the width and height are 16 by 16, so the rectangle will cover this whole tile. When x is 1, it's 16, 0, so it's going to be in this spot right here, and it's the same 16 by 16 square, so it'll be this rectangle. I'll just highlight it really quick. I'm sure you guys are catching on. Whoops, this. Holy cow. This. Nice. And then when x is 2, it'll be at 32, 0, which will be this. And then when x is 3, it'll be at 48, 0. And then when we go to the next line, it'll bump the y value up. So we'll do this one, so on and so forth. Very nice. Thank you, GitHub Copilot. And by the way, I use Control KD to do auto formatting. If you ever see the whole text file get auto formatted at any point, that's what's going on there. Okay, cool. Just thinking ahead a bit, when we draw the game, let's go there right now. There's some stuff that we draw every single time, but there's also additionally some stuff that we'd like to draw depending on the game mode we're in. So for instance, when we're in the level editor, I want to draw the currently selected tile that you're going to be placing, but when you're playing the game, we don't need to be drawing that. So inside of the draw function itself, I'm also going to switch on the game mode. So say game mode play, game mode level editor, no, break. And in here, we'll say level, or actually I can just say, I like draw level editor. Draw level editor. Okay, cool. And then underneath our draw function, I'm just going to add a new function called draw level editor. Nice. And then kind of what I was saying is that the sprite I would like to draw is the current tile option that the player has selected. and I would like to draw it at the current mouse position. So what we can do here is we can say sf vector to f v mouse position, and it's going to be the same function that we use in the handle update input, or I'm sorry, handle input, where we get the mouse position. And then the next thing we're going to do is we're going to say for our tile options, for the tile option we have selected, we're going to set its position to the mouse position. And then finally, we are going to want to draw that tile option. So we'll go mwindow.draw, and we're going to draw the tile that we have currently selected. Cool. And then additionally, I said it would be nice that if you use the scroll wheel to go up and down, that we change between the tile options. So let's see how difficult that will be. Handle input. Okay, this is sort of the same thing we're coming up to with the draw, which is that, okay, when we're handling our input, there's some input that makes sense to be called for the general case, but it would also be nice to have some specified input depending on what game mode we're in. So if you remember right now, all of our input for the regular game, if we just go to update play, is all handled in here. But maybe it would be nice to move that outside of this, just so that update play can focus more on the playing and the gameplay rather than the input stuff. So if we go back to handle input, what I'm going to do is I'm going to add another switch here on the game mode. And then we'll say case, play, handle play input, and then we'll say case level editor, handle level editor input. Cool, very cool, very cool. And then if we go back to the header file, when we handle input, we'll also say handle player input and handle level editor input. Some housekeeping. You can see this grows really quickly, but it does give you a ton of power and control, and setting things up like this ultimately ends up being much more resistant to bugs because everything is just operating as you expect it to. So now in the update level editor, instead of handling all of this input here, we're going to handle the level editor input inside of handle level editor input. Fantastic. And then inside of our play mode, we'll handle this in there. And then one little caveat is we'll need to add a couple member variables, because right now we're only storing the player's requested movement locally, but we'll want to be storing this just on the game itself. So I am going to add, let's see, this is for play mode, and this stuff is for level editor mode. So inside of this, we're going to add a vector called player requested movement, and then we'll also add a float called player speed. And then here we can just say player requested movement, and then we can replace all of the instances of player, place like this, and then this one will be doubled. Okay, cool. We're not going to initialize it here. And then we'll say f speed, and we'll replace this with the new variable, new member variable. Very cool. And then we don't need it here. And then the last thing we want to do is we want to initialize these to some value. Okay, so they're above the tile index. So we'll say MV requested player movement is 0, and we'll have a speed of 100, which is how we had it set up before. That says speed is undefined. Oh, I called it player speed, which is probably a better word for it. I think that, does that mean the enemy also uses the player speed right now? Where do we move the enemy? I don't know. Why can I not see this? Enemy. Enemy speed. Oh, I have an enemy speed right there. Okay. So the enemy speed, there is an enemy speed set up. It's not saved as a local variable right now. I'm sorry. I keep saying that the opposite of what I mean. It's not saved as a member variable right now, but that's okay. Oh, duh. And then one thing we need to do at the very beginning here is we'll set it back to 0 before we add all the values into it. So if we look at that now, very cool, very cool. We'll switch to level. Oh, and look at that. So we switch to level editor mode, and it draws the brick that we have currently selected. Okay, the next thing I want to do is add the functionality where when we do the scroll wheel in and out, it changes the index. So we have to capture the Okay, we have to capture the scroll wheel event, and to do that we need to add, holy cow, Andrew, is everything okay? SF event closed window.close. Yes. Okay, to do that we need to capture this mouse wheel scrolled event inside of the window polling. So pardon this input stuff. This is from another project. I just copied over this case just because I forgot how to do it. So I'll put this in here, and then we'll just clean up the miles of white space and nothingness that I just created. And then the last thing to note is I don't know why this just isn't in our handle input function. I think it probably should be. So I'm going to cut this out and put this in handle input so we can handle key presses here. That's fine. But then we can also handle our window events. And I think this should still work. Whoa. What is it not happy about? Oh, I started typing something else here that didn't work. Okay. Oh, actually, I think it is going to yell at us. No, it did not yell at us. Very surprising, because we would get all the way to draw and the window would be closed. Okay, who cares? So it still works. So the next thing we need to do is, if this scroll is up, I don't remember which way is which, but I suppose it doesn't really matter that much. Okay, what I'm gonna do here is I'm gonna add another enum, and you can already see this class is growing a little bit out of control, but it's whatever. I'm just gonna call it scroll wheel. Scroll wheel input, and I'm going to say scroll up, scroll down, none. And there's probably a better way to handle this, but you have to remember that right now we're checking this scroll wheel status just sort of in the abstract. It's just in our regular old update function. So this will be captured whether or not you're in play mode or you're in the level editor mode. So this is right above the tile index, and we'll just set this to none. And then inside of handle input, when we scroll, let's just pretend like this is scroll up, and this will be scroll down. And then I suppose before this, we could probably just set it to none. That'll make it so if you don't utilize the scrolling, then it gets reset on the next frame. So for instance, if you were to scroll while you're in play mode and then switch to level editor mode, you wouldn't want the tile to change right away. Anyways, okay, so we handle the input, and then we'll go to the handle level editor, and then here in handle level editor, we'll say if scroll wheel input equals, wow, I cannot get over how quick this is. We'll say if scroll wheel input equals scroll up, then we want to increase the tile input index. If the tile input index goes past the end, so remember we have 16 types of tiles, so the index will be 0, and then as we scroll up, eventually it'll hit 16, and we don't have a tile for that. So once we get to that, we'll loop back around to the front. We'll go back to 0, and then when we go the opposite way, when we are decrementing, once we get to -1, we'll set that to the end of the array, or not the array, the vector. So now if we save this, go into the game, go to level editor mode, and then use the scroll wheel, you'll see we have green, red. All right, it's not in the order that I expected it to be. So it goes like brick, white, 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 green. Oh, okay. Whoopsie. So it doesn't really matter which order we have it in, but if you look at this, I'm doing X first and then Y. So when X is 0, we actually go through all of the Y's going down and then go over. So we're doing it column wise. And yeah, I would prefer that we go row wise. So I'm going to change this first outer loop to Y's, and then the inner loop to X's. So this will do it by rows across rather than columns down. So now if we go into level editor mode and I scroll up, it goes red, blue, green, white, 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 and then back to the brick. Okay, cool. And then the final thing that we need to do here is set up the clicking. So when we click, we want to create a tile at this position. So what we need to do is, if you can imagine the game as a grid system, sort of like this texture sheet is, you might, anywhere you click within this first rectangle, that's where you want to draw or set down the sprite. Same thing for the second one, same thing for the third one. Whether you click in the corner here or you click in the middle, you want the sprite to be aligned with the grid. You don't want it to go exactly where your mouse is, or else that would be complete chaos. Actually, putting it where the mouse is kind of an interesting idea, though. I don't necessarily hate putting it exactly where the mouse is. I know in the past I said stick to norms where your players expect them to and deviate only when it's really a good idea. And I don't think that putting tiles completely aligned with a tile map is necessarily something that has to be true. But anyways, I digress. For this video, we're going to keep it simple, and we're going to keep it sticking to the grid system. So if you remember, our tiles are 16 by 16, but then they're blown up 10 tiles. So on the screen, they actually occupy 160 by 160 pixels. So in order to figure out the XY position of them, if you were to say this top tile is 0, 0, the next one is 1, 0, the next one is 2, 0, 3, 0, and so on and so forth, we can use sort of just like a couple quick tricks with how math works in programming. So if we just take the X position and divide it by 160, because X is an integer, which just means that it's going to be a counting number. So numbers like 0, 1, 2, 3, and not a decimal number like 1.5, 1.8. If you take the position of the mouse and you divide it by 160, you'll get the X position, because if the mouse's position is, let's say, 150, and you divide it by 160, it'll be some fraction between 0 and 1, and then the computer needs to turn it into an integer, so it always rounds down. We can do the same thing for the Y position, and then what we want to do is we want to check, well, let's simplify this a little bit. So the first thing that we want to do is we want to create a tile at that position. So we'll say SF sprite tile equals, and we can actually just set it to the current tile that we have as our tile option. And what this will do is it won't make it literally that tile, but what it does is it'll copy all of the information from that tile into our temporary tile, which is convenient because it'll have the texture set, it'll have the origin set, it'll have the scale set. The only thing that it has that's not useful for us right now is the position. And then the next thing we want to do is we want to set the position of the tile. And hey, look at that. GitHub Copilot already knew how I wanted to set the position of the tile. So remember, we draw the tile from the center of it. So we don't want to just draw at X times 160 and Y times 160. We want to draw it at X times 160 plus 80 and Y times 160 plus 80 to get it nice and in the middle of our screen. And then the final thing that we want to do is we want to add this tile to our list of tiles. And then additionally, in our draw function, we need to draw all of the tiles. And the one thing I'm going to do real quick is I'm going to draw all the tiles first, because order of operations matters here. So the first thing that you draw gets put on first. Think of it like layers of paint. So we're going to paint all the tiles, and then we'll paint the enemy, and then we'll paint the player. So they'll look like they're on top of the tile. So I'm going to say draw all of the tiles. And this is, thank you, GitHub Copilot. So a fast way to iterate through all of the tiles in a vector is using this notation. It's sort of similar to C#'s for each, but it's just it's essentially C++'s for each loop, where we say for every tile in tiles, draw that tile. Okay, cool. Whew, okay, let's see what happened so far. So we're in play mode. We click T to go to the level editor mode. We left click and we get a tile. But one thing that is not obvious is that these tiles, right now there's nothing stopping us from drawing another tile on top of this tile. And what you'll actually realize if you're thinking about it is we're not replacing these tiles when you draw them on top of another tile. They actually are just all stacked on top of each other. in this huge list. So if you keep doing this, eventually you have an absolutely massive vector filled with way too many tiles, and things would get out of hand. So what we want to do instead is when we go to create a tile, so I'm going to go create tile at position. Before we push back the tile, what I'd like to do is go through all of my tiles. So I'll say I is less than m tiles dot size. And I'll say if it's just too good, I don't know what to say. If tile I position equals the tile we're trying to place's position, pardon me. Okay, and what we want to do here is a little vector trick. So if you want to erase something in the middle of a vector and the order of everything in the vector doesn't matter, which for a tile map, it really doesn't matter, because if it did matter, then that would mean that the order that you draw the tiles affects the game. And that should not be the case. You should be able to draw the tiles in any way you want, and it should still work. So the trick here is that you have, you have your list of tiles, and what you're going to do is the tile that you want to erase, which is the ith tile, you're going to set that equal to the tile at the very back of the list. So we'll go m tiles dot back. And so now at this point, so let's say you had 5 tiles and you wanted to erase the third one. The first thing you do is you say, make the third tile equivalent to the tile at the back. And then the next thing you do is you destroy the tile at the back. And what this ultimately ends up doing is just destroying what was at the third spot by replacing it with what was at the back. Why this is faster, why do we have to do this in C++, is because the vector is a contiguous chunk of memory. And if you wanted to remove something out of the middle of it, you would leave a gap. So what the vector would have to do is move every single item past that spot over one spot. And that would be slow and tedious and potentially unnecessary. So we don't have that sort of option purposefully, because it's not performant. And that's what C++ is sort of all about. So this whole set this to back, pop back, this is a very common thing you'll see in C++ programs. A lot of things have essentially this whole functionality wrapped in another sort of function called erase fast. But I just looked at the standard template library for vector, and it doesn't look like we have erase fast available to us. Anyways, just getting back to this. So when we create a tile at a position, the first thing we'll do now is say, hey, check if there's already a tile at the position. If there is, delete it. And we do that by doing this little fancy dance where we first set the tile we want to delete to the one in the back, and then we pop it. Okay, I've said this 100 times now. We're going to move on. The next thing we want to do is delete the tile at position. And because I already wrote create tile at position, it just knows exactly what I want. Well, we'll see. So we have the mouse position. We do the same function above to get the X and Y. And then this time we don't need to create a tile. We just need to know the position. So we'll create the tile position, and then we loop through all of our existing tiles. And then if we find one whose position matches, we'll do the same little trick to delete it. And this is when we right click. So now if we run the game and we go into tile editor mode, we can draw tiles with left click. And then if I right click, we'll delete the tiles. Cool. I think that's probably enough for today. We've set up a lot today. We didn't just do the tile editor, we also refactored a bunch of our game. But I think in the next episode, what we should add is some way for these tiles to have a personality. So right now, if I click T and go back into play mode, these tiles don't do anything. I can run right through the wall, and red doesn't hurt me if it's supposed to be lava or something. And it would be fun if they had a little bit of pizzazz to them. Additionally, it would be cool if we could save the tile map and then reload it, and maybe even have the option to save different versions of the tiles. And then maybe, for level editing, we could iterate through our levels and change them and change where the enemies are and change where the tiles are. And then in play mode, we can play through the levels. And then once you finish a level, it loads the next level and so on and so forth. All of these things would be cool, but I'm going to wrap this up now. I hope you enjoyed the video. I hope you learned something. I really appreciate you watching, and if you can leave a comment with feedback, I'd really appreciate that. If you could subscribe, I would, be very grateful. And yeah, thanks so much for watching. Have a good one.